Good morning to everyone. Myself, Dr. R.C. Chauhan, Associate Professor, Samrat Prithviraj Chauhan, Government Classes Mere. Today we will discuss MSc Physics Semester 2nd, Paper 5th, that is Classical Electrodynamics, and the unit is 2nd. The topic for today is the pinch effect. What means of pinch effect? What means of pinch? Mostly we say in our daily lives, if someone we are the new class, then we say this is pinch. Then what means of this pinch in the physics? So this is related with the plasma, and the definition for it is the compression of an electrically conducting filaments by a magnetic forces is called the pinch effect. Mostly the conducting medium is there treated as a plasma. So what it say means, if the current is flowing through the any conducting medium, then it's produce a magnetic field. The current flowing produce itself induce a magnetic field which is perpendicular to the flow of the current, and this will be forces the ions and the electrons toward the center or the axis, and this effect is known as the pinch effect. So what is the basic mechanism of the pinch effect? This is the basic, the first step mechanism is there, and there is the figure. In the first figure, here we can see first figure, that is a conducting medium like the plasma is filled in between the two high potential plates, positive and negative. So when the high voltage is applied on the conducting medium, mostly the fluids, or they can say fuels, maybe fusion fuel also, and the voltage is the very high, then it ionizes the gas or the materials, and due to this one, the plasma or any conducting medium is converted into the positive ions and the electrons. The second one, due to this one, the electrons are free, so the current will be from the high potential to low potential, like in this figure, that is from top to bottom. So current flow, or you can say jump in the gap to the two ends, positive and negative. You can say the electrons will be flow by the electrons in this one. Positive ions will be remains there, and due to this one, they are also responsible for the current flowing, but you can say mostly are stably there, or can say they are moving in this in between the plates. Second one, this current induced in the magnetic field which is perpendicular to the direction of the current flow, F equal to Q V cross B. Mostly the magnetic field is like this one, by using by Sauer's law, that is the particular magnetic field is there. That is shown by the curved lines perpendicular to the current flow from the top to bottom. So this is in the curve flow. The third one, this the current produced in the magnetic field perpendicular to this one, and the fourth, the magnetic field pulls the materials together, or can say these atoms get close to each other, close enough to this one, like this one, the tube will like this one. Inside this one, there is the shrink in between the plates, and on the top and bottom there will be the higher area. So this effect is the pinch effect, and this is the mechanism of the pinch effect in the plasma or any of the fusion materials. That is also used for the confinement of the plasma. Now the derivations related with this one is that, let us consider a cylindrical column of the fully ionized quasi-neutral plasma with an axial electric field producing an axial current density J vector, and its associated azimuthal magnetic field B by using the Sauer's law, and as the current flow through its on, it produces its own magnetic field, and a pinch is generated within the ionized, or that is the inward radial force density J cross B. We know very well that force equation is related with such type of the fluids and the electrodynamics, and that is root dV by dt equal to minus del P plus J cross B plus Fp plus rho G. Here Fp is the viscous force related, rho is related with the gravitational force, and del P is related with the pressure gradient, rho dV by dt, that is related with simply the net force. and J cross B is the magnetic force. So using this one we can indirectly write, if the all forces are included in the force F, then we write rho dV by dt equal to the F minus del P J cross B. If we neglect the viscous and the gravitational force and the other remaining force, mechanical forces effect on this one, and the condition is in equilibrium, means net force is 0, and for that one we can write del P minus J cross B equal to 0, or the del P equal to J cross B. Del P is the magnetic pressure gradient. This is the pressure gradient due to the magnetic field, and this is equal to J cross B. Here the P equal to the PE plus PE. PE, that is the due to the electron pressure gradient, and the Pi related with the ions, so both are related to each other, and added to provides the net magnetic pressure gradient. Now using the Maxwell equations, del cross B equal to the mu 0 J, and it's the ideal equations, gas equations, P equal to NKT, we can write twice NKTE plus Ti equal to the mu 0 4 pi I square. And using the sum calculations, we have write N is the number of electrons per unit length, here not volume, and I is the total current. On the multiplying the above equations, we can also obtain the other forms. Equation first, we can write B dot del P equal to the B dot J cross B 0, because we say J cross B and the B is equal to each other, so that's why it is cos 90 equal to 0, so it is 0. So this show that the direction of the B is direction of to the del P, or we can say B is perpendicular to the del P. And the second case, J dot del P equal to J dot J cross B. Yes, here is again, because direction of the J cross B is perpendicular to the J vector, so cos 90 is again 0, so it is 0. So this so that the J as well as the B both are perpendicular to the pressure gradient. So equation second and third show that the B and J both are perpendicular to the pressure gradient del P, so this will be the decide the direction of pressure gradient. And that is like in the figure, that is a surface series of the constant potential, and that is the J and B, or you can see like this one, some angle. This shows the force J cross B, also the points toward the axis. This means the plasma is confined, or you can see there is a net force inward the axis, and that is responsible for the confinement of the plasma to contact in particular bottle, magnetic bottle, just like we can see, by the electromagnetic force J cross B, and this is known as the magnetic confinement. And this proves that this is the conclusion related with this one, that the phenomena of the confinement of the plasma or the conducting fluids by the self-magnetic force is called the pinch effect. So today we have discussed what is the pinch effect, what is the responsible for the pinch effect, what is the direction of this one, the magnetic gradient, magnetic force pressure gradient, and how it is used to produce the magnetic confinement like the plasma in bottles. So for today it is sufficient. Thank you very much.